Today we'll be looking at arc length and area of a sector. In the given diagram for example 1, you are asked to find the radian measure of the angle, and the radian measure is denoted by theta. They give us that the arc length is equal to 0.12 meters and that the radius is equal to 10 centimeters. So you should have noticed that one of them is in meters, the other one's in centimeters. We always want to make sure we're in the same units of measure. So what I'm going to do is times 0.12 by 100, convert that to centimeters, and get that the arc length is 12 centimeters. So the formula from the previous video for arc length was S equals R theta. If I plug in S as 12, R as 10, and solve for theta, I get that theta is equal to 1.2 radians. Now, if you don't see the word radians at all, you will assume that it's radians unless you see the degree symbol. So we most likely will be in radians for the majority of our calculations. So 1.2 radians. Now part 2 is how do we find the area of a sector? And if arc length is a piece of the circumference, we're going to think of the area of sector as a piece of the area of a circle. So you want to think of it as a slice of pizza, a slice of pie. So it would make sense that our formula is derived from the area of a full circle. So down about halfway down the page, I'm going to go ahead and derive the formula. So we know that the area of a full circle, getting ahead of myself here, the area of a full circle is equal to pi r squared. And in SL Geo, when we were learning about the area of a sector, which you did learn last year, we used degrees, and we would put the angle that was given in terms of degrees over a full revolution around the circle, which would have been 360 degrees. For us, the angle measure in radians is going to be usually called theta, and the full revolution around a circle in radians is 2 pi. Remember, that's equivalent to 360 degrees. Now we can reduce out the pi and come to the formula that you'll see in your textbook, which is 1/2 r squared theta. So on example 2 and 3, you see the circle on the left with the angle measure of 7 pi over 6. That arrow is to indicate that you have an angle that is bigger than 180 degrees. If we think of 180 degrees as equivalent to pi from the previous video, then 7 pi over 6 is past pi. So if we want to find the arc length of that, and let's go ahead and highlight it, they want us to find this arc length right here. Given that we know theta is equal to 7 pi over 6 and that the radius is 4 centimeters. So finding the arc length is simple enough. We plug in r is 4, the angle measure is 7 pi over 6, and we reduce to get 14 pi over 3. So if it's asked for in terms of pi, that would be our final answer. If it's not, just punch it into the calculator and come up with a decimal approximation. So for the area of a sector, 1/2 r squared theta. This is a formula that will come back in Calc BC when you guys are finding area for polar curves. But for now, it'll be just of sectors within a circle. So here we have 1/2 r being 4 squared and theta again being 7 pi over 6. So if we take half of 16, we get 8 times 7 pi over 6. And we reduce this to be 4 and 3. Our answer in terms of pi is 28 pi over 3. Now I want you guys to keep in mind that the theta you see here in the arc length formula, as well as in the area of a sector, these need to always be in terms of radian and not degrees. If it is presented to you guys in the initial problem in terms of degree, we're going to convert it to radians before we plug it into the formula. That concludes our lesson on arc length and area of a sector.